Come, let's go eat. It's still early. Confirm got parking one.
Yalla, impossible full so fast. Let's go.
Oh no, why are there so many cars?
And why is everyone side parking?
We came here to eat, not to tour the parking lot.
My hunger is slowly becoming anger.
Eh, the spot got taken.
There goes our dreams.
Parking and traffic congestion have become common issue within our community. Drivers spend excessive time searching for parking, and this lead to vehicle idling, which increase the carbon emission and fuel waste, and it also make it difficult to confirm the arrival time due to uncertain parking availability, and ultimately, this unpleasant parking experience will reduce the visitor numbers and directly impact the business revenue. To understand the problem better, data collection was conducted through social media discussion and feedback from students and friends, identifying that parking management as a major concern in public spaces. Therefore, our group proposed a smart parking system and developed a prototype to visualize our idea, integrating Arduino Uno, ultrasonic sensor, LEDs, and servo motor as our hardware, alongside with a Python Qt5 as our interface, SQLite database, and YOLO with Easy OCR for license plate recognition. Finally, testing and evaluation were performed to verify the sensor accuracy, hardware response, and overall system functionality. The main objective of this system is to reduce the time users spend searching for parking. User can either check available slot and make a reservation before arrival, or be automatically assigned a slot upon arrival. With the implementation of our smart parking system, your brain might be bombarded with concerns such as when the elderly or visitor enter without the app, unauthorized parking, parking reserved without showing up, or even being the cause of traffic congestion in the parking bay when the user has insufficient balance upon trying to exit. Therefore, our system also considers this challenge in order to improve the overall parking management experience.
Now, let's dive into the prototype and how it works. I'll start off with the user interface, which consists of two main windows. The first window prompts the user to enter their registered car plate number or to register via the Register Here button. Once verified, it displays their name, plate number, and credit balance, then transitions to the main screen. Firstly, on the top left corner here shows a drop-down list, enabling the user to select a place for the parking. In the middle, the vehicle's car plate is shown alongside the user's current credit balance, which can be reloaded through the credit function via the top-up button. A clickable button next to the top-up button is the Payment History button, which shows the date, time, and the type of fee imposed, such as the parking fee and its location. Next up, the current parking fee to be paid is displayed here. Once entered, the system would start counting and deducts the balance automatically upon exit. The system has also integrated a low balance reminder function that triggers a pop-up window whenever the user has a low credit balance, such as 5 ringgit or below, as shown here. Thus, this solves the traffic congestion due to insufficient credit balance.
To visualize Objective 1, the user can log into the system. Choose any green vacant slot and make a reservation. The parking slot will then be reserved, and both the LED light and the system will show a yellow color. User is given 15 minutes to arrive at the parking slot. What if the car park is fully occupied? The waitlist feature in the system provides an opportunity for them. It will show the current number of waiting cars. If the user decides to join the waitlist, they will be notified once the parking slot becomes vacant. The parking slot will be reserved once the secure button is pressed. From here, Objective 1 is achieved. Upon arrival, the barrier gate will automatically open after the camera detects the car plate number. The system will then display the reserved slot and a map showing the route to the reserved slot. The map will keep looping until the user clicks the Garlic button, ensuring that the user can successfully reach the correct reserved slot. Once the car arrives at the slot, a confirmation pop-up appears to verify the user. After confirmation, the LED light will change from yellow to red, indicating the occupied condition. However, another issue that may arise is no-show reservations. To solve this issue, the system includes a violation feature. If the user fails to park within the 15-minute period, a 10 ringgit penalty fee will be automatically deducted from the user's credit balance. Therefore, this penalty system helps reduce and prevent no-show reservations effectively. If an unauthorized vehicle is detected instead, the buzzer activates immediately to deter the offender, and the rightful user is auto-assigned the next available slot with no disruption. From here, the issue of unauthorized parking is solved.
For Objective 2, when a registered user arrives without prior reservation, the system automatically assigns the nearest available slot to the mall entrance. A route map then guides the user directly to their slot, eliminating unnecessary idling and search time. The same time allowance and confirmation will be shown in this case. To ensure user-friendliness, non-app users such as the elderly can freely park at any slot with green light. Their car plate is captured for billing at the entrance, and the payment is settled at the counter upon exit, just like a conventional parking system. Since the project securely stores all parking data in our database, the project has massive potential for future scaling and improvement. The first is an analytic dashboard which displays peak hours, average stay duration, and daily revenue. Using this data, operators can apply dynamic pricing to regulate customer flow and make business decisions such as expanding capacity or developing new locations. Beyond that, this data can be fed to an AI prediction model that estimates when the next slot will be vacant, giving waiting user a projected wait time. Next, dedicated disabled slot can be automatically reserved for OKU user only, with management instantly alert if an unauthorized vehicle parks there.
Moving on to market potential, this session will be evaluated across 3 dimensions: sustainability, in terms of the carbon emission avoided, revenue potential in terms of government procurement and carbon credit potential, and scalability. Based on literature, the concerns used are average search time of 3.5 to 14 minutes, crawling speed of 10 km per hour, fuel efficiency of 9.5 km per liter, and a petrol combustion factor of 2.35 kg of carbon dioxide per liter. Taking the median search time of 8.75 minutes, each car covers 1.46 km per search, consuming 0.1535 liters of fuel, resulting in 0.3607 kg of carbon dioxide emitted per car per search before implementation. Post-implementation, we assume search time reduces to 3 minutes, making a difference of 4.25 minutes. Applying the same constants, the carbon saved is approximately 0.1752 kg of carbon dioxide per car per search. At 500 cars per day, that is 32 tons of carbon dioxide saved per year. Next, revenue potential, in terms of government procurement and carbon credit potential. Under government procurement, Malaysia's commitment to net zero by 2050, intensified in the 13 Malaysia Plan, drives demand for measurable urban solutions. Our system delivers exactly that: clear, auditable outcomes, including idling time eliminated, fuel saved, and emissions avoided, making it suitable for government procurement under a single framework. Malaysia launched Bursa Carbon Exchange in 2024, with carbon trading as a vision in the 13 Malaysia Plan. Bursa Carbon Exchange currently focuses on large-scale forestry, and our 32 tons per year does not yet meet the 1,000 unit threshold. However, our system already generates measurable carbon value annually, growing as the market expands. The system can be scaled from a single site to districts, cities, and nationwide, replicating the same architecture without rebuilding. Every new site compounds the impact: more carbon saved, more data, and greater carbon credit eligibility. Beyond revenue, the system generates broader social impact. Fewer car circling means less traffic congestion, lower noise pollution, and reduced carbon emissions in surrounding areas, directly improving the urban living environment. Academically, easier parking drives higher mall football and retail spending, while drivers benefit from direct fuel and time savings. Reduced emissions also lower air pollutant exposure in surrounding areas, easing public health costs. To wrap up, our smart parking system delivers real value for everyone. For the general public, it saves time and costs and contributes to a greener, more sustainable city. For businesses, it boosts revenue and improves operational efficiency. Simple, scalable, and ready to make a difference. That will be all from us. Thank you for listening.